Welcome to the class. Today topic is um, organic compounds. Organic compounds. Let us start the question. Organic compounds containing nitrogen. Okay. In previous NEET questions, now we start the first question. Uh, First question is the correct order of basic strength of methyl substituted amines in aqueous solutions is. Okay, how to solve this one? Uh, methyl substituted amines in aqueous solutions. Methyl substituted amines in aqueous solutions. Let us focus. Let us think about methylamines. Methylamine. Now I am writing methylamine. This is known as CH3, and this is tertiary amine, methyl substituted amine, and then you write this is methyl substituted secondary amine, methyl substituted secondary amine, and methyl substituted primary amine. This is primary amine. According to inductive effect, according to inductive effect, uh, more substituted methyls, methyl sub, more substituted methyl groups, more substituted methyl groups. Okay, more substituted methyl groups, more substituted methyl groups, because here the substitution, methyl substitution is greater. Okay, three methyl groups can donate the electrons to the nitrogen. Nitrogen can give the electrons easily to the other one. Okay, here two methyl groups are available. So two methyl groups are available here. So then this nitrogen can give electrons slowly then compared to this one. This is based on inductive effect. Methyl groups are electron donors. Electron donors. Electron donors. Electron donors. According to inductive effect. According to inductive effect. Inductive effect. Okay. Here there is only one methyl group can donate the electrons to the nitrogen. Can nitrogen donate the electron, this lone pair of electrons, to the other one? Is less chance than compared to this one, and this one has less chance because only one methyl group can donate the electron to the nitrogen. Then only it can donate the electron pair to the other needed electron needed compounds. Okay. In this scenario, generally we think tertiary has 3 methyl groups, secondary has 2 methyl groups, primary has 1 methyl group. So we expect tertiary is more basic than secondary than primary. But the real scenario, it is different one. Only one thing can change this one is steric factor. Tertiary has steric effect, means these bigger methyl groups can restrict to donation of electrons of nitrogen to the other compound. This effect, these methyl groups restrict, or it can obstruct. These bigger atoms can obstruct donation of these electron to the other compound is known as steric hindrance. This is known as steric hindrance. Steric hindrance. Steric hindrance. We call it as steric hindrance. Steric, S-T-E-R-I-C-K. Steric hindrance. Steric hindrance. Due to steric hindrance, this is less basic because there is three methyl groups can give electrons to the nitrogen, but these groups are abstract to donate the electron to the other one easily. This is known as steric due to steric factor. This is less basic than compared to the secondary. So finally, what we are saying is secondary is more basic than compared to the primary, tertiary and tertiary. And next one is primary, and next one is tertiary. Okay, because of this steric factor, this is steric effect, this is secondary is more basic than primary, and this one tertiary one is very weak basic than even compared to the primary one. Okay, that is the reason why order is secondary, primary and tertiary. Okay, you can observe another way in in this way similar question you may get it. Ethyl amines. In ethyl amines, if you have the same question on ethyl amines, if you get the question ethyl amines, then okay, ethyl amines, similar question on ethyl amines. On those times you can get secondary, tertiary and primary. The answer will slightly change for ethylamine scenario. For methylamines in this question, this is the correct answer. Okay, let us see how it will which one is correct one. Okay, secondary, primary and tertiary, B is the correct answer. Okay, next focus the amines, second one. The amines that react with Innsberg reagent to give an alkali insoluble product is let us think about Hinsberg reagent. HIN's Hinsberg's reagent. Benzene sulfonyl chloride. Benzene sulfonyl chloride on reaction with for example primary amine ion. Okay, this is primary amine and H2. You can get the product like this. SO2 NR NHR. This HCl is removed in this reaction. Then it has acidic hydrogen. Here. Okay, it has acidic hydrogen here. This is the acidic hydrogen. Which is that is the reason why. How can we say this is acidic hydrogen? Because this is electron withdrawing group. Okay, let us write again. You can understand like this. SO2 NHR. This is electron withdrawing group. Beside the electron withdrawing group, hydrogen attached the nitrogen atom or whatever it may be the atom. This we call it as acidic hydrogen. Acidic hydrogen. Acidic hydrogen. Acidic hydrogen. Let us write again. Acidic hydrogen. Acidic hydrogen. Acidic hydrogen. That is the reason why, due to this acidic hydrogen, which is soluble in alkali. Soluble in alkali means basic. This is soluble in alkali. Whereas in secondary, okay, if we get secondary amine, HNRR, this is secondary amine on reaction with Ainsworth reagent ArSO2Cl. We may write like this. This is reaction is like this. Then product is ArSO2 N R2. Okay, let me write this NR2. So this compound does not have hydrogen. No hydrogen, no acidic hydrogen. No acidic, no acidic hydrogen, no acidic hydrogen, no acidic hydrogen. So which is insoluble. So if it has acidic hydrogen soluble in alkali, okay, react with alkali NaOH like that base. In no acidic hydrogen, no soluble in alkali. Okay, not soluble, not soluble, not soluble in alkali, not soluble in alkali. So, what is the correct answer for the second question? Is A is the correct answer. Let us look into this. This one is secondary amine, which is what they ask us. Ainsworth reagent to give alkali insoluble product. This one gives the alkali insoluble product. This is B question. Not react with Ainsworth reagent. Not react with Ainsworth reagent. Ainsworth reagent not react. Okay, because no acidic hydrogen. Here there is no acidic hydrogen, not react. This one react and this one. These are primary amines. These two are primary amines. Okay, these are primary amines. These are primary amines. These two react like this and they are soluble in alkali. Okay, there is a reason why this is similar to A is similar to this one. This is the correct answer for this question. Next question. Nitration of aniline in strong acidic medium. Third question. Nitration of aniline in strong medium also give meta nitroaniline because yes. Okay, this is in text question. In text question, you can understand this acidic medium, strong medium, aniline present in aniline ion. That is the reason why you can get that one. Okay, let us explain the in text question. Third in text question, like this: aniline in presence of concentrated H2SO4 plus concentrated HNO3 in these two, in presence of these two, you can get different products. NH2 NO2 here para NO2, and you can get NH2 and NO2, and 49 percentage you can get this one, meta directing NO2 product. And then you can get another product, that is NH2, sorry, here NO2, here NO2. Okay, how we can get this is orthopara directing group? The question is, this is orthopara directing group, orthopara directing group, orthopara directing group. Okay, in this situation, these two generate the NO2 group, electrophile NO2 plus. NO2 should substitute ortho or para. Whereas in this case, you can get meta directing group also. Why it happens? The question is why this happens. The answer for this question is in the acidic medium, this is acidic medium, H2SO4 is acidic medium. In presence of acidic medium, aniline get converted into NH2. Aniline in presence of H plus is get converted into some chances to get into NH3 plus. This is known as anilinium ion. Anilinium ion. Anilinium ion. Anilinium ion is a meta directing group. This is orthopara directing group, but this is meta directing group. Meta directing groups. That is the reason why you can get this type of product also. They mention like that. Okay, you can understand easily. Yes, in acidic medium, aniline present in anilinium ion. That is the reason why you can get nitration of aniline in strong acidic medium gives meta-nitroaniline because of this one, this factor. Next, fourth question. The correct increasing order of basic strength of the following compounds is correct basic strength. Oh, this is very easy question. You can understand it. In first one is aniline. The second one is nitroaniline. Second question is para-nitroaniline. Para-nitroaniline in this NO2 is electron withdrawing group. It can pull the electrons from nitrogen. It can pull the electrons, lone pairs from the benzene. So, whereas in this case, third case, CH3 is electron releasing group. It can release the electrons to this group. So, finally, we conclude that releasing group is more basic. If there is a releasing group present in the aniline, here it is an electron releasing group. This is the more basic. So, third one is more basic than aniline. Okay. Next, NO2 is electron withdrawing group, so it cannot give the electrons easily. That is the reason why withdrawing group presented, that one is less basic. This is the C is the correct one. Okay, based on electron releasing groups, you can predict this one. Next case. Which of the following reactions is appropriate for converting acetamide? The fifth question. Focus the fifth question. Okay, let us wait. Let us rub this scenario, and then we can start freshly to understand these concepts very clearly. Okay, you can write again here, then we can get the clear ideas regarding the previous bits what we expect. Okay, let us focus. Come here and let us focus. Which one of the following reaction? Which one of the following reaction? Which one of the following reaction? Reaction, fifth question, appropriate for converting acetamide to methanamine. What is the formula of acetamide? First of all, acetamide formula, CH3 C double bond O, C double bond O, that is NH2. This is known as acetamide. Acetamide on reaction with Br2 and NaOH, you can get methanamine. You know from the in-text question, this is in-text question from NCERT book, Hoffman bromide, this is known as Hoffman bromide degradation. Hoffman bromide degradation, acetamide is get converted into methanamine. Methanamine. Okay, this is a simple one from the NCERT textbook. Okay, most of the questions are NCERT book here. Then this is not covered in NCERT book. The question is like this: which one of the following nitro compound does not react with nitrous acid? Okay, nitrous acid. Which one can react with nitrous acid? Nitrous acid means HNO2. Which one can react? Okay, which one? Okay, which one of the following? Which one of the following nitro compounds does not react with nitrous acid? So answer is clear. Is if this group attached carbon contains hydrogen can react with HNO2, then if not, they cannot react with HNO2. In this context, these have hydrogens, so all are react, but this carbon at NO2 attached carbon not having hydrogen, no hydrogen, so not react. No hydrogen, so not react. So no bother about that. This is the simple way you can remember this one. Next question. Okay, next question. This is also you can rub it and then add another question here. Oh, that question, like, let's focus the question. Seventh question. A given nitrogen containing aromatic compound a given nitrogen containing aromatic compound A react with SN by HCl followed by HNO2 gives unstable compound B. B on treatment with phenol forms a beautiful colored compound C. Which one of the molecular formula NO2? The structure of compound A is okay. What they said is a given nitrogen containing compound containing aromatic compound A react with SN by HCl followed by HNO2 unstable compound B on treatment with phenol from beautiful colored compound molecular formula. What is the structure of A? Okay, let us see the answers. Okay, from our observations we know, let us assume B is our target. Okay, B is A is B. Okay, compound A is B. Then you can go and you can get the answer. Okay, why we are taking B is the one A. How we can go through this one? Because of the our previous knowledge, you can take B straight away, and you can write Sn by HCl is a reducing agent which can provide hydrogens. So on reducing reagent reaction, you can get the product is okay. Let's, let's get the product is let's think about the product is okay. uh, NH2 NH okay, that's whole weight. This is the reduction scenario. Okay, removal of oxygen removal, and addition of hydrogens. Okay, addition of hydrogens, removal of oxygen. Takes place simultaneously. You can do it. Then focus followed by reaction with HNO2. On reaction with HNO2, you can get on reaction with HNO2, you can get N2 plus Cl minus. This is unstable one. Okay, unstable product. B on treatment with phenol forms beautiful colored compound C. Okay, this is on reaction with phenol. You can get the product like this. Is this Cl and here another hydrogen in phenol, para hydrogen are removed, then you can get beautiful colored compound. This is known as coupling reaction. This is NCERT textbook, same ditto. This is dye. Okay, colored dye is formed. So molecular formula, you can compare this one, the same molecular formula you can get it. So that is the reason why the answer of this question is B. Okay, this is very easy to understand. This one is from NCERT textbook. So most of the questions are NCERT textbook except sixth question. All are NCERT textbook. So straight away they given the straight away they ask us. Okay, next one. Eighth question. Let us focus. Eighth question. The correct statement regarding the basicity of aryl amine is. Okay, we know aryl amines and alkyl amines. Which one is more basic? Okay, let us think of. Let us think. Aryl amine, and let us think of aryl amines and alkyl amines. Here, alkyl amines means CH3 NH2. Like these are the this is the alkyl amine. This is aryl amine. Aniline is the aryl amine. This is alkyl, this is aryl. This is alkyl amine. Alkyl amine and aryl amine. Which one is more basic? Generally, alkyl amine is more basic than aryl amine. Okay. How can we say aryl amines? Why it is less basic? Because there is a delocalization of electrons. with 5 electrons. There is a chances of migration of electrons like this. These 5 electrons are migrate, and this is the electrons it can donate like this, and you can get the resonating structures. Means NO2 and NH2 plus. There is a chance of getting this type of structure. So availability of these electrons is less than compared to the availability of lone pair of electrons. Availability is more in alkyl amine than compared to the uh, than compared to the compared to this one. So availability of electrons is less for donation. Availability of electron is more for this one. So answer, let us focus the answers. Aryl and alkyl amines. Aryl amines generally more basic. The answer is than alkyl amines. So this is wrong one. And next, aryl amines generally more basic than alkyl amines. More basic. This is also not correct. Aryl amines are generally less basic than alkyl amines because nitrogen lone pair of electrons are delocalized by interaction with aromatic 5 electron system. This is the correct answer. Okay, what we saw here is aryl amines. Electrons are delocalized, then this is less. Aryl amines are less basic than alkyl amines. So now this is the one. And next class we can deal with from 8th to remaining questions. Okay.